Hello everyone. Now let's do one more example on the cut point grouping method. So cut point grouping. Let's just have a small data set to work on. So let's say we have 0.5, we have 1, another 1, 1.5, 2.5, 3.0, 3.4, 4.5, 5.0, 5.1. Okay, so this is the data set. Since we have numerical values with decimals, then we have to use this cut point grouping method to organize this data set. So first step, we're going to order or sort this data set from the smallest to the largest. So now that the data set is given in increasing order, so this step done already. And then step 2, we're going to calculate the range. So range equals the maximum minus the minimum. So the largest number is the maximum, which is 5.1, and then the minimum number, the smallest, which is 0.5. So we got the range equals 4.6. And then step 3, we're going to calculate the width. The width equals range divided by number of classes. So range is 4.6, and number of classes proposed, let's just use 5. So this is given equals 5, and then we can calculate the result, which is 0.92. So for width, we always want a easy calculated number. So 0.92, we just round it up to 1. Because compared to 0.92, 1 is way more easier for the later calculation. So we round it up to 1. And 0.92 and 1, they're not too far away, so it won't influence the classes that we gonna generate. So now next step, we're gonna just make our table. So our class, which is from the smallest number. The first class is always from the smallest number to a upper limit, which is the smallest number, the lower class limit at the width. And then we want to say frequency, relative frequency. Let's just do frequency and relative frequency for this one. So the smallest number is 0.5. So we write 0.5. And then use this notation, 2 smaller than. Smaller than means up to this upper limit but not included in this class. And then how to get the upper limit, use the lower limit, which is this value in this class, plus the width, which is 1.5. And then next class, we're going to start from 1.5. So now 1.5 is inclusive in the second class. 2 smaller than 2.5. And then we have the second class. The third class is going to be 2.5, 2 smaller than 3.5. And then 3.5, 2 smaller than 4.5. And then 4.5, to smaller than 5.5. And another question is when to stop. We can keep generating the classes. When to stop? When we have one class upper limit, which is 5.5 now, is more than the largest number you have in your data set. The largest number we have is 5.1. So now 5.5 is larger than 5.1. So you can find a spot for every single value in your data set now. So you can stop. Now let's count. We have 1, 2, 3, 4, 5 rows. That means we have 5 classes. So 5 classes. So the number of classes proposed. So number of classes proposed is 5, and then we actually have 5, so which is good. And then now we can just put the frequencies there. So 0.5 to smaller than 1.5. We have 3 values because 1.5 is not inclusive, slightly smaller than that, to up to this number, but not include in this level. So the frequency is 3 for this one, and then 1.5 to smaller than 2.5, we have 1, and 2.5 to smaller than 3.5, we have 3, and then 3.5 to smaller than 4.5. We have no value in this class, then we'll just put 0. And then 4.5 to smaller than 5.5, we have 1, 2, 3. So the frequencies we have are going to be 3, 1, 3, 0, 3. And then we're just going to add up all the frequencies to check whether we have the same value as the sample size. So 3 plus 1 plus 3, that's 7 plus 3, that's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values. So n equals 10, which is matched with the total. So no problem. And relative frequency, we can just use 3 divided by 10, which is 0.3, 0.1, 0.3, 0, 0.3, and then that's going to be 1. Okay, so now we finish another example for the cut point grouping method.